Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of PW Gulf. So students, I welcome you all to your Triumph batch. Basically this is your ultimate recap session. Until now we have done sessions, so you very well know that we are going to revise over here. Yes, my dear students, you heard it right. So we are going to do the recap, that means the revision of complete chapter Surface Chemistry of our class 12 standard. So students, be prepared with your notes, be prepared with the NCERT because we are going to revise the complete session in this particular class. Yes, everybody. So now, ma'am, how are we going to proceed? What are the segments we are going to cover? And initially, do we need to write each and everything? How questions are asked from this particular chapter? See students, if I'll talk about surface chemistry, from this basically theoretical based questions are asked more. For example, if I'll talk about examples are asked more, in each and every term that you are going to understand over here, they will ask you more and more examples with regard to that. So whensoever you are hearing any example, you are hearing any example or you are writing anything, just put it, a circle or a box so that whensoever you are reading it, you are going through your notes, you can revise it properly. So shall we start with our today's class? Yes students, how are we going to cover this particular class? As you very well know, this is the ultimate recap for the chapter Surface Chemistry. Yes, now see basically students, if I'll talk about today's target, ma'am, how are we going to proceed? What are the segments we are going to cover? So we shall be starting with the very basic segment of ours, that is going to be the introduction session. Here in introduction, we are going to understand about two basic terms, that is adsorption and absorption. Yes, after that students, there are more terms, regard to surface chemistry. So we are going to cover all the terms with regard to surface chemistry such as sorption, desorption, adsorbate, adsorbent. We are going to cover that. After that students, we shall be studying about the types. About the types of adsorption such as physiosorption, chemisorption. I guess you know very well that it is physical adsorption, chemical adsorption. Yes. So we are going to understand that in depth. Then we are going to see, the graphs. That is, we are going to understand about Freundlich equation. Yes, now this also you should know that x by m is equivalent to kp raised to the power 1 by n. See students, this is an ultimate recap. I would suggest that yes, this session is basically making you a revision, okay. So if you have not heard this chapter before, it will help you throughout in detail because we will be covering out each and every part. But this is a recap, right? This is for a quick revision that you can just recall all the things. So for that, do read your notes, properly in detail with NCERT. For this, open your NCERT, that is a good way to complete the session. Open your NCERT, listen to me, write it over there, underline it over there, you will get your answer. Yes? Now, after Freundlich equation, we shall be understanding about the application part. And after application, students, we shall be starting with the catalyst. What is catalyst? What are the types of catalyst? What is promoter? What is activator? What is poison? Yeah, so we are going to understand that. After that students, we are going to understand, about homogeneous catalysis, heterogeneous catalysis, the adsorption theory, very, very important, the adsorption theory. We shall be focusing upon that. Then we shall be covering, we have seen catalyst, then we will be saying about enzyme, and the mechanism with regard to that as well, with some examples over there. After that students, we shall be starting with the topic that is colloids. What are colloids? Right, and what is classification of colloids? Classification of colloids. If I move further, after classification, we shall be seeing the properties, the method of preparation of colloids, the purification of colloids, and at last we shall be looking up to emulsion. So these are the segments that we are going to cover one by one. Let us start with the general introduction session of our today's chapter. So basically, what is adsorption, what is absorption if I'll talk about? Let us take a small example. Students, you have, a sponge. When you are dipping that sponge into water, the water moves into the sponge. That means it is a bulk phenomena in which the particle moves inside. The water particles goes inside the sponge. So that is absorption. Now let us take a general example. If you take a chalk and you just take an ink and you spread your chalk over there, the ink will gather around the surface. Let us say you are just doing it for few seconds, for 1 or 2 seconds. So it is not going inside, it is outside. So that is a surface phenomena. You are applying a nail paint. It is not going inside, it is on outside. So that is what is basically adsorption, which is a surface phenomena. So in short, if I have to define what is adsorption, what is absorption, here we have D, here we have B. Adsorption basically is your surface phenomena, and what is absorption, ma'am? Ma'am, it is bulk phenomena. It is bulk phenomena. Now over here, what are we going to see? We are going to see the interaction of particles. Ma'am, which kind of particles? See students, till now we have studied the chapter solution, in which we got to know that solution is made up of solute as well as solvent. Yes. So that was for the case of solution. But what about these cases over here? Over here, what are the particles? Over here, the particles basically, here I am referring to in a different term, not in the case of solute and solvent. But over here, when I am talking about that here, in the case of adsorption, I am still talking. In the case of adsorption, there shall be an interaction between adsorbate and adsorbent. Now, what are these, ma'am? What is adsorbate and what is adsorbent? See, again repeating, this is surface phenomena, this is bulk phenomena. This process occurs on the surface, right? That means here interaction is between adsorbate and adsorbent. Let us understand. Let us consider this is your surface. The surface on which adsorption occurs, that is adsorbent. And the molecules which basically are doing the surface phenomena, now they are coming and doing the interaction, which will in future looks like this. So these molecules over here are adsorbate. They are adsorbate. And what about them? It is adsorbent. So the interaction between adsorbate and adsorbent is your adsorption. Clear, everyone? Now absorption is the bulk phenomena. Now if you are getting confused, you can even do like this. For example, this is your beaker. This is your liquid. The innermost particles are your bulk particles. And the surface particles over here, these are your surface particles, so that you won't get confused over here. Now we shall start with the very basic difference between both of these. Here you can see the table and you can directly note down this table. I'll explain you each and every point over here very clearly. See, here is written as absorption, here is written adsorption. I will let you know what is adsorbent in detail, but first of all, let us understand the difference. See, what is absorption and what is adsorption? Absorption, already told, it is a bulk phenomena, it is a surface phenomena. Here, the concentration of particles is same throughout. Why? Because it is a bulk phenomena. Bulk means inner particles. So the concentration is same throughout. While over here, if I'll talk about the concentration of particles on the surface of, adsorbent is different than the bulk. Now only we have seen, no, the particles that are present inside and the particles that are present on the surface are different. They are not same, right? Their amount is different, their concentration is different. Next, rate of absorption is uniform. Why? Because it is evenly spread. What about adsorption? Rate of adsorption is fast in the beginning. But yes, with regard to time, it will decrease. With regard to time, it will decrease. Okay. Now, next is, it is a slow process. Sorry for this. It is a slow process. It is a fast process if I'll talk about adsorption. Right? Clear, everybody? The very basic difference you very well know now. Now, what is the thermodynamics of adsorption? Very simple thing. Adsorption means interaction of adsorbate particles with adsorbent particles. That means if we are considering, we have, a solid particle over here, which is our adsorbent, and we have these gas particles. If we are applying some kind of force so that they can do some interaction, these particles and these particles do some interaction. So we are applying some force, right? What will happen? These particles which were in air now are getting stick to a position. Now it will look like this. These are adsorbent particles, these are adsorbate particles. Now they have been fixed to a certain position. So what about entropy? Entropy is the randomness of a molecule. Entropy is basically here and there molecules are revolving around, moving around. So here now they are stick to a position. That means entropy now here decreases. That means randomness over here decreases. So let us see about the thermodynamics of the adsorption. See here enthalpy will also be negative. Entropy will also be negative, and if we will find out the delta G, which is equivalent to delta H minus T delta S, this also comes out to be negative, which hence proves that this is basically a spontaneous reaction. Yes, let us understand it. See, when a gas is adsorbed on the surface of adsorbent, over the movement of molecules gets restricted. They will stick on the surface. Now, this leads to decrease in the entropy. I already told you delta S will be negative. Also during adsorption, residual forces decreases on the surface leads to an exothermic process, due to which delta H is also negative. Clear everybody? That's great. That's great. Now let us talk about types of adsorption. See, basically there are two types of adsorption. One is physisorption, other is chemisorption. Physisorption basically in other terms is physical adsorption. In other terms is physical adsorption. And if I talk about chemisorption, in other terms it is chemical adsorption. Yes. Now let us understand about physical and the chemical adsorption. In physical adsorption, there will be the force that I would say will be weak van der Waals forces. While in the case of chemical adsorption, it is going to be chemical bonding that participates over there. So if I talk about physisorption or physical adsorption, it is caused by intermolecular van der Waals forces, which are basically your weak forces. And if I talk about them, these are caused by the chemical bond formation, which is going to be very strong. So that means if I talk over here, this can be reversible. This can be changed back into the reactant. Why? Because it is weak forces. But this is strong forces, right? So this cannot be reversed back. It is irreversible in nature. So this is reversible, this is irreversible. Yes, the next point. Over here you have to, there is no need of any activation energy. No activation energy required to perform this particular reaction. Because no chemical bond is being formed, no? It is basically a kind of van der Waals force, right? No, not chemical bond, covalent bond I am saying too. Here no activation energy is required. Here you have to give activation energy. Here activation energy is required so that reactant can be converted into product. Yes, moreover, it depends upon the nature of gas. Next part, it depends upon the nature of adsorbate and adsorbent both. It only depends upon the nature of gas. More liquefiable gas, more it will be adsorbed, right? Easily liquefiable will be absorbed more. Next, heat of adsorption over here is low. Heat of adsorption over here is very high. Now, they have a tendency to form multi-layers like this, multi-layers on the surface. All of these will form multi-layers because they show weak van der Waals forces. While here it is chemical bond, so only one layer will be formed, unilayer. Only one layer will show interaction with adsorbent. So it is unilayer formed in the case of chemisorption. This question is generally asked in examination as well. Now students, moving on to the next part, we are going to start with factors affecting adsorption process. So there are certain factors that affect the adsorption process, such as nature of gas, nature of solid, pressure and temperature. All of these factors basically you can correlate very easily. Right, so now you cannot, interact a polar one with a non-polar one, right? So in case of nature of gas, you can do the interaction of polar one with the polar ones. Okay, non-polar one with the non-polar ones, then only interaction will be seen. Moreover, in nature of gas, you can say the, more liquefiable gas, more will be the adsorption. Easily will be the adsorption. If I talk about the pressure case over here, if you are applying more pressure from the top, adsorption will increase. Why? Adsorption is interaction. So if you are applying pressure, it is going to interact with the adsorbent particle. So it will increase. Now let's talk about temperature. If you are providing temperature, the particles will move here and there. Initially, particles had a certain geometry. When you gave them the temperature, the particles will now move apart here and there. Hence, adsorption will decrease. So this is the way how you can understand the factors that affect the adsorption process. Now, what are the application of adsorption process, students? Let us understand about the applications in day-to-day life where it is basically used. So, if we'll talk about the very first part, it is used in the production of high vacuum, students. How we are implementing this process over here? See, the remaining traces of air can be adsorbed by charcoal from a vessel evacuated by a vacuum pump to give a very high vacuum. So basically here, we can adsorb with the help of charcoal, and it can be used for the production of high vacuum. The next is gas mask. Now this is really very important. See, in sometimes what happen, now let me give you one more example. If I talk about activated charcoal, you have seen that the miners who who go for the mining process below the earth, in order to do the mining processes, they wear a mask over there. Now the mask basically contains what? It acts as an adsorbent. It will engulf all the harmful gases and will protect the miner, the person that is going down in order to do the gas mining process. So when he goes down, what happens? He will absorb all the harmful gases, hence the person will be safe. Otherwise, he or she can get affected over there. So gas mask basically act as an adsorbent, activated charcoal. Even if you'll see, when you buy a new bag, you buy a new leather bag, you get a pouch over there, right? So that pouch basically is also acting as an adsorbent, so that all the harmful things get adsorbed at that surface and it won't get affected. So basically gas mask, a device which consists of activated charcoal or a mixture of adsorbent, is usually used for breathing in coal mines to adsorb poisonous gases, so that it won't go to the nose, it will just get adsorbed at the mask. Next is control of humidity. So silica and alumina gels are used for adsorbent for removing moisture and controlling humidity. Right. Next part is removal of coloring metal from the solutions. Now this is also one of the applications, you can say. Animal charcoal remove colors of solution by adsorbing colored impurities. Yeah. So adsorption basically is a surface phenomena. So everything comes to the surface, interacts with the surface, right? Next is heterogeneous catalysis. This we are going to do now also. See, adsorption of reactant on the solid surface of the catalyst increases the rate of reaction. What is the rate of reaction? That means they are increasing the speed of the reaction. Now, there are many gaseous reactions of the industrial importance involving solid catalyst. Example they have given you for the manufacture of ammonia, in the manufacture of ammonia, that is Born-Haber's process. How it is done? It is basically N2 plus H2 producing NH3. Over here, you take basically iron as a catalyst and molybdenum as a promoter. Right? For this case, you take iron as a catalyst and molybdenum as a promoter. Okay. Now here heterogeneous catalyst is acting as an adsorbent. Manufacture of H2SO4 if you are doing by the contact process, you use nickel in the hydrogenation process, nickel, platinum, palladium, right? These are the catalysts that are used. So are excellent example of heterogeneous catalysis. Yes. Next comes separation of inert gases. Due to difference in degree of adsorption of gases by charcoal, students, a mixture of noble gases can be separated. So they can be separated out with the help of taking charcoal as an adsorbent. Next part, in curing diseases, a number of drugs are used to kill germs by getting adsorbed on them. Just as the mask does, in the same way it works, right? Now, the next application is froth flotation process, which you shall be understanding in the metallurgy chapter in depth about froth flotation process. A low-grade sulfide ore is concentrated by separating it from silica and other earthy matter by this method, where we use pine oil and the frothing agent. So in detail we shall be doing this in metallurgy chapter, but yes, you can understand this also works with the adsorption process. Now comes adsorption indicators, right? So surfaces of certain precipitates such as silver halide have the property of adsorbing some of the substances, like some of the dyes like eosin, okay, these dyes, and so it will act as an adsorbent. Next, chromatographic analysis also, you can see thin layer chromatography experiment. There, capillary action, with the help of capillary action, the mobile phase, moves on to the upper particle and we can see the adsorption being seen on the chromatography paper. So, thin layer chromatography, paper chromatography, all of them work on the basis of adsorption process. So, these were application, students. Now comes the adsorption theory of heterogeneous catalyst. Let us understand this in depth first of all. See, this is basically the adsorption theory. You have to understand that catalyst basically has some space on it, the free vacancy. Now this free vacancy is left in order to create bonds, and then let me tell you one more thing. Catalyst basically reacts, it takes part in a particular reaction, but it will come out as it is, as you have taken it initially. It will basically it will come and participate, but it won't react. right? It will participate in the reaction, but it is just to help the reaction to takes place more faster. So this is the surface of catalyst, and we have A and B reacting molecules. Now if A and B are the reacting molecules, what they will do? First of all, diffusion will occur. Now what is diffusion? Diffusion is movement from one place to the another place. So A and B basically diffuses to the surface of catalyst. When they are diffusing to the surface of catalyst, they are coming towards catalyst. Now they have done the diffusion process. When they do the diffusion process, now they have reacted with the catalyst A and B. Now what they will do? Now they will react with themselves. So now see, this is basically absorption. Here adsorption will come. Adsorption of the reacting molecules. Now what are they going to do? They are going to react with each other. See, they are going to react with each other, and then there will be desorption. I already told you that I will be explaining you the terms like desorption, sorption. So what is desorption? Desorption basically is a removal of particles from adsorbent. Now over here, adsorbent is our catalyst surface, and these are adsorbate. So when they are getting removed, that is desorption. See what will happen? First they will diffuse, they will come, then they will interact, then they will interact. Sorry, they will come, they will interact. When they will interact with each other, after that the bond will break. That will be desorption process. So over here, after diffusion, they came together. Now the bond breakage occurs, that means desorption, and they will be come together as a product, that is AB, and catalyst again will be left same as we took over here. Clear? So this is adsorption theory, very simple theory. Yes, everybody. Now there are some features of solid catalyst. In which of the following, let me tell you over here, zeolites is very important, right? Which is a shape selective catalyst. Let us understand about the features of solid catalyst. So see, if I'll talk about activity, see, activity of a catalyst basically and importantly depend upon the strength, how the chemisorption occurs, right? So activity of a catalyst depends upon the strength of chemisorption to a larger extent. Now, the reactant must get absorbed reasonably strongly onto the catalyst to become active. However, they must not get absorbed so strongly that they are immobilized, and other reactants are left with no space on the catalyst surface for adsorption. What they are saying is, for example, if the process is being taking place, right? So one particle, two particles have done, the interaction with catalyst. Now the adsorption should be to a limit. It should be not to a larger extent, so that they cannot be, so that desorption cannot take place. They should occur to a certain limit so that it can now move on, and the next particles will come and interact with each other. So it should be done at a particular amount. So activity is this, okay. It is found that for the hydrogenation reaction, now in organic chemistry you will understand about hydrogenation process, where nickel, platinum, palladium is used as a catalyst, okay. The catalytic activity increases from group number 5 to 11. Now this question is also asked, okay. Metals with maximum activity, which is maximum activity among them, is shown from group number 7 to 9 elements. So do remember, they can ask you the direct question. Next part, I already told you about selectivity. Selectivity term itself says that for a particular reaction to occur, you have to provide a particular catalyst. This is what is selectivity. Okay, the selectivity of a catalyst is ability to direct a reaction to yield a particular product. For example, if you have to yield C, so you should know that A and B will produce C, A and D won't produce C. So for a particular product to obtain, you have to provide it to a particular catalyst. So this is selectivity. Now you can see, when under the same reaction conditions, many products are possible. Yeah. So under the same condition, many products will be seen, but for you have to obtain a particular product, so you have to provide a particular catalyst. Now, selectivity of different catalysts for the same reaction is different. For example, they are saying when you react H2 with CO using different catalyst, you get different products. Various products. Thus, it can be inferred that action of catalyst is highly selective in nature. Highly selective in nature. As a result of substance which act as a catalyst in one reaction may fail to catalyze another one. So, this is what it is saying. A particular catalyst will act for a particular reaction. This is what is selectivity. Now come, about the types of catalyst. There are two types of catalyst, homogeneous catalyst and the heterogeneous catalyst. See students, if the phase of reactant and the catalyst is same, it is homogeneous one. If the phase of reactant and the catalyst is different, it is heterogeneous one. Now what is phase? Phase is basically solid, liquid, gas, right? So if reactant and your catalyst are in solid form, they are homogeneous. If reactant is in solid, catalyst is in liquid form, or opposite of vice versa, they're different. I meant to say that it is heterogeneous one. So let us read about homogeneous. When the reactant and the catalyst are in the same phase, that means liquid or gas if we are talking about. The process is said to be homogeneous catalyst. The following are some of the example. Any example you can learn over here. I have taken an example of SO3 formation. See, now oxidation of sulfur dioxide, that means SO2, into sulfur trioxide, that means SO3. Okay, with dioxygen in the presence of oxides of nitrogen as the catalyst. Here you are taking nitrogen oxide as a catalyst, okay, and this is occurring in the lead chamber process. So nitrogen oxide is again a gas, and over here reactant is also gas. So both of them are in gaseous form, hence it is a homogeneous catalyst. Clear? Now coming to the next step is a heterogeneous catalysis. If I talk about heterogeneous catalysis, the catalytic process in which reactant and the catalyst are in different phases, I told you, is heterogeneous catalysis. Now what are the examples? The very first example is oxidation of sulfur dioxide into trioxide in the presence of platinum. Platinum, right? So platinum is solid in nature, and here this is gaseous in nature, different phases. So if different phases, students, heterogeneous catalyst. The reactant is in gaseous state and the catalyst is in solid state. So this is an example of heterogeneous. Moving on to the next one, we have mechanism of enzyme catalyst. The lock and key mechanism. What it is exactly? The lock and key mechanism. Let us understand the lock and key mechanism. Very simple. See, basically enzyme has a particular, design or a shape which is complementary to the shape of substrate. Now understand what is substrate. Substrate in other words is reactant. Now reactant is going to react with enzyme, it will form enzyme substrate complex, and then it will lead to the production of product. It is basically a lock and key mechanism. Again repeating, enzyme creates a supplementary shape, a complementary shape so that it can fit it over here, such as lock and key. Basically lock has a certain shape so that key can fit over there. Similar way, substrate will react with enzyme, will create enzyme substrate complex, which on further will yield us what? Will yield us product. For a particular reaction, a particular enzyme is used. Okay, everybody write down this important diagram or just make this important diagram because it is really, really very, very, very important. It is highly efficient, highly sufficient, highly effective. Yes, everybody, these are the characteristics for an enzyme. Highly efficient, highly specific, highly active under optimum temperature, highly active under optimum pH. Clear, everybody? Now students, these are some examples of enzymes. Enzymes, I guess you all very well know, in the biology you have read about enzymes in detail. What are enzymes? Enzymes are proteins or the one which have a large molecular mass. So you very well know about what are enzymes basically. See, now they have told you for which reaction, which enzyme you are going to use. For sucrose, the conversion of glucose and fructose, right? When they are going to do, invertase enzyme is being used. Over here, zymase is used. From starch to maltose, diastase is used. From maltose to glucose, maltase is used. So these are the enzymes. You can learn any of the three. Yes, everybody. Now, this is the lock and key mechanism which I have already told you. See, enzyme basically acts as a catalyst over here only. It has a complementary state. Also, one thing more. Substrate has an active site where enzyme comes and react. Okay. So, when this enzyme and substrate will react, it will form enzyme substrate complex, and after that, it will lead to the production of product. Right? Now, students, comes our next topic, that is going to be colloids. That is going to be what, ma'am? Colloids. Before that, we just skipped the topic, that is adsorption isotherm. Let us do that first. See, adsorption isotherm basically is showing you, a graph between what? A graph between the gas adsorbed on a particular adsorbent with respect to time or with respect to pressure, students. This is what is adsorption isotherm. Basically, if you are going with respect to pressure, it is adsorption isotherm. If you are going to with respect to, x by m with respect to temperature, it is isobar. Always remember, isotherm, that means same temperature. So, if you are taking same temperature, that means you shall be obtaining a graph between x by m and pressure. Between x by m and pressure. And the graph basically says that x by m is equivalent to Kp raised to the power 1 by n, and you are going to obtain this kind of a curve. This kind of a curve. Yeah. So this is basically given by Freundlich adsorption isotherm. And if you have to draw a graph between x by m and t, that is going to be adsorption isobar. Let me explain you what they are saying. What is X over here? What is M over here? X is basically the gas adsorbed. M basically is the, it is adsorbed at how much? Adsorbent. So M basically is the mass of the adsorbent where the gas is getting adsorbed. So here 1 by N value lies from 0 to 1. If you will put 1 by N value as 0, what you are going to get? X by M is equals to Kp raised to the power 0. X by M is equals to K into 1. That means it becomes what? Constant. So that means this value over here lies for when 1 by N is 0. This value lies over here when 1 by N value is 1. If we will put 1 by N value is 1, what you are going to get? X by M is equals to K into P. That means it is directly proportional to pressure. If you are increasing pressure, X by M, adsorption will increase. And this value basically lies from 0 to 1. Clear everyone? So this is adsorption isotherm graph. Now students, coming to the next point, that is about colloids. What do you feel? What is a colloid? Colloid basically, students, is a heterogeneous system in which one substance is dispersed phase as very fine particles in other substance called dispersion medium. Now coming to the topic, we very well know that solution is made up of two substances, solute and solvent. In the similar way, when we are talking for the case of colloids, basically this is for the case of true solution, we use solute and solvent. But for the case of colloids, we have dispersed phase, and dispersion medium. So when dispersed phase and dispersion medium combine, they are going to form colloids. Dispersed phase in other terms is your solute, dispersion medium in other terms is your solvent, right? The one which is present in less quantity solute, the more is solvent. So this is vice versa, but in colloids we have used dispersed phase and dispersion medium. So their interaction basically forms a colloid. Yeah, in which one substance is dispersed phase, another one is dispersion medium. Now if you are going to classify colloids, we can classify colloids on the basis of three categories. The initial one is physical state of dispersed phase and dispersion medium. The second one is nature of interaction between dispersed phase and dispersion medium. Third one is type of particles of the dispersed phase. So let us start with the physical state interaction. So this is the classification. Here this is the dispersed phase, phases: solid, 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 liquid, 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 gas, gas. This is dispersion medium: solid, liquid, gas, solid, liquid, gas, solid, liquid. Then the types of colloid that we form. Now how you have to see, when you are dissolving solid into solid, it will form solid sol. Examples are given. When you will dissolve solid into liquid, it will form sol. When you will dissolve solid into gas, you will form aerosol. When you will dissolve liquid into solid, you will get gel. When you will dissolve liquid into liquid, you will form emulsion. Now emulsion, let us do it over here only. Emulsion basically is what? When you are going to dissolve liquid into liquid, that means your dispersed phase is also liquid, your dispersion medium is also liquid. Now emulsion is of two types: oil in water, water in oil. Okay, your first homework question for today's class is write down the examples of oil in water and water in oil. Your first homework question is write examples for oil in water and water in oil. See over here if you will see students, both the mediums are in what? In liquid state. Dispersion medium, dispersion phase, both. Now comes liquid and gas. When you dissolve liquid and gas, it will form aerosol. Gas and solid, solid sol. Gas and liquid, foam. Right? Let me tell you, mark important ones that you should know. You should know, students. Now solid and gas is aerosol. Liquid and gas is aerosol, very important. Only solid and liquid, this also and this also. Among these, what you have to learn, which are generally asked: milk, smoke, soap, and fog. Yeah, so these are generally asked. Clear everybody? Clear everyone? Now students, let me discuss about the next types over here only. If I'll talk about the nature of interaction between dispersed phase and dispersion medium. Let us talk about the nature of interaction. How dispersed phase and dispersion medium are going to do in the interaction process with each other. Yes, students. So with this we can say lyophilic and lyophobic. It can form lyophilic and lyophobic ones. What are lyophilic and lyophobic? Lyophilic is liquid loving and lyophobic is liquid hating. Liquid loving and liquid hating, lyophilic and lyophobic. Do you know what is hydrophilic, hydrophobic? Hydrophilic is water loving, hydrophobic is water hating. So again, on the basis of nature of interaction, if they are interacting properly with the liquid, that is lyophilic. If they are not interacting properly, they are hating each other, that is lyophobic. Everybody write down so that I can start with my third part. The third part, multimolecular, macromolecular ones. Yes. You can take some examples of lyophilic also, gum, gelatin, starch. Okay. In lyophobic, you can take metal, sulfides, these examples. Now, types of particles of the dispersed phase. Let us consider the very first is multimolecular. Next is macromolecular. And last is associated colloids. See now what happens. See, basically you have to see when all of these particles come under the colloidal range, they will be said to multimolecular, macromolecular, associated colloids. How? See, when small particles, when little particles come together and will create a particle size which comes under the range of colloids, that is multimolecular. Okay. If I'll talk now, example for this is gold sol. Okay. Let us take for macromolecular. For example, big particles come together and will create a solution which comes under the range of colloid, that is macromolecular. Let us talk about associated colloids. In the case of associated colloids, let me tell you, at low concentration, particles behaved as strong electrolyte. When you provided higher concentration, what was seen? Missile was formed. At higher concentration, missile was formed. Missile basically is a jhag in Hindi terms, right? How missile formation occurs? It occurs in the case of soap solution. How it looks like is, it basically looks like this. The cleansing action of soap. So this is the creation of missile. How missile is created, let me tell you. Initially, you had low concentration, so they were behaving as a strong electrolyte. But as soon as the concentration increased, what happened? All the particles arranged themselves in such a way and they created a missile. Now, what I am drawing over here, this is basically the carbon chain that I am doing. This is basically the hydrophilic head and this is basically the hydrophobic tail. So they will arrange themselves in such a way that if in water they assemble themselves, it creates a missile. This is what is associated colloids. And the temperature at which this occurs basically is Kraft temperature. Okay. And the concentration at which it occurs is critical missile concentration. This is basically the soap solution that you always do. Now comes the preparation, students. So preparation method is chemical method. That means over here what are you going to do? You are going to do with the help of chemical reactions such as double decomposition, oxidation, reduction and hydrolysis. You can obtain your colloids. Okay. Now you can see sol is being obtained. You know how sol is being obtained. Now only have put a star over there, right? So when you dissolve them together, you will obtain these by the chemical methods. Do mark them in your NCERT. These are important. Now the next method if I'll talk about is electrical disintegration. What is electrical disintegration? When you are providing a certain electricity in order to obtain a solution which comes under the range of a colloid, right? So that is what it is. This process involves dispersion as well as the condensation process, all of them all together. The next part, colloidal salts of metals such as gold, silver, platinum, etc. can be prepared by this particular method. Examples again are really very important. The next part, in this method, electric arc basically is stuck between electrodes of the metals which we have immersed. One is anode, one is acting as a cathode. Right, next, the intense heat produced vaporizes the metal which then condenses to form the colloidal particles. So, we are going to provide the electricity and going to obtain the particles which come under the colloidal size. The next method is peptidization method. Next method is which method, ma'am? Peptidization method. So over here you can clearly see that what happened basically here precipitate is being formed. How? Now see, peptidization can be done if you are converting a precipitate into a colloidal particle by shaking it out. So see basically, peptidization may be defined as the process of converting a precipitate into colloidal solid by shaking it with dispersion medium. With dispersion medium, do remember that. With dispersion medium along with some presence of electrolyte. Electrolyte is something which dissociates into its ions, right? And it is strong electrolyte and weak electrolyte respectively. Next, electrolyte used for this purpose is peptizing agent that you are going to do in order to obtain the colloidal particles. Now, this method is generally used to convert a freshly prepared precipitate into a colloidal sol. Next, during peptidization, the precipitate absorbs one of the ions on the electrolyte itself on its surface. This causes the development of positive and negative charge on the precipitate. Clear everyone? Now comes the purification method, how you are going to purify them, right? The very first method is dialysis. Dialysis, now in the kidney process also you have heard about it, right? See what happened in the dialysis process, you are going to take a membrane, that is dialysing membrane. It is a process of removing a dissolved substance from a colloidal solution. You're going to separate it all together, you're going to purify it all together, right? By means of diffusion through a suitable membrane. This suitable membrane is the dialysing membrane. And let me tell you, this is a slow process in comparison to the electrodialysis. If I talk about electrodialysis, here you are providing electricity so that the movement of the particles can be done in a faster mode, right? Over here, the process of dialysing is quite slow. It can be made faster by applying a, electric field over there. Okay, so this process is named as electrodialysis, and the colloidal solution is placed in a bag of suitable membrane while pure water is taken from outside. This is the process. Here just you are applying the electricity and the movement takes place faster. The next, students, we are going to start with the properties, and the very first properties of the colloidal particles is Tyndall effect. Tyndall effect basically is the scattering of light. Yeah. Tyndall effect is what? Basically the scattering of light, and you all are very well aware that whensoever we say that here at this particles, it will, see, if you have to see the properties of colloidal particle will scatter the light. So if you are providing some source of light, it is creating a Tyndall cone, it is scattering light in all directions. That means this is the colloidal particle that is present over here. Now the question from the Tyndall effect is, what are the conditions on which Tyndall effect can take place? So my second question for today is conditions for which Tyndall effect occurs. No need to worry, in the next lecture I am going to give you its answer, but I want you all to think about it. Think about it, okay? The next part if I talk about is electrophoresis and electroosmosis. In electrophoresis, students, there is a movement, of colloidal particles. Movement across the dispersion medium. Here, electrophoresis, you are applying what? Electricity. What will happen? See, this is anode, this is cathode. All the negative particles will move on to the positive one, and the positive one will left over. So, negative and positive will be separated, right? Here is a movement of only colloidal particles in the dispersion medium. But if I talk about electroosmosis, over there, complete dispersion medium particles from one direction to the another direction takes place. Movement of all the particles in the case of electroosmosis. Clear? The next, students, that comes out to be is Brownian motion, Brownian movement. The Brownian movement basically is the zigzag movement of particles. It is basically the zigzag movement of colloidal particles. So that is what is Brownian movement. No need to worry again, students. The purification part we are going to cover in depth before starting the next session. This is just to give you an intro over here for the purification. Rest we have covered the complete chapter though. But as purification I want to do in detail. So I am going to take 15 to 20 minutes more, in the next class itself when we will be doing the next chapter. Along with that I will be covering this, the purification part. Clear everyone? So yes, students. So here we are going to end our today's session. Again repeating, the purification part we shall be covering in the next lecture in the next chapter itself, with the next chapter. So the rest of the chapter I hope so is ultimate recap for you, is an ultimate revision for you people. Now we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much my dear students. Thank you so much and take care.